Okay, so in this video, we've got a function and we're going to do 3 derivatives of this. The first time we're going to take the derivative, I'm going to use the quotient rule. The second time I take the derivative, I'm going to apply the product rule. And then the last time, to find the derivative, I'm going to manipulate the function algebraically and then differentiate so that I don't have to use the product or the quotient rule. Okay, so 3 different ways I'm going to take the derivative of the same function. So the first one, I'm just going to do the quotient rule. Low d high minus high d low all over the square of what's below, or all over low, whatever, right? So what is it? Low is x, d high, the derivative of the numerator, the derivative of 5x to the 4th, bring the 4 out front, that's 20, and then subtract 1 from the exponent, that's x cubed, okay? And then plus, now bring the 2 out front, multiply, that's 14 times x to the 1, and then the derivative of 3 is just 0. So low, d high, minus high, so all that goes in the parentheses. D low, the derivative of x is just 1, all over low, so x times x is x squared. Now I need to simplify the numerator. I'm going to distribute the x through. So x times 20x cubed is 20x to the 4th, and then x times 14x is 14x squared. Now I have a negative 1 multiplied through, so that's going to make all those terms in there negative. So minus 5x to the 4th, so minus 7x squared, minus 3. So now I'm going to collect like terms. I have a 20 and a negative 5 makes positive 15, x to the 4th. Then I have a 14 and a negative 7 makes positive 7, x squared, and then minus 3, that constant by itself there. Now I have 15x to the 4th divided by x squared. Guess what? There's 4 x's up top, 2 down low, so the top wins by 2, so it's x squared in the numerator. Here I have an x squared here and x squared there. Those cancel, so that just leaves me 7. And then here I have 3 and then x squared. So that's just going to be 3 divided by x squared right there. So that's my answer right there. So that is the derivative of all 3 of these. But now we're going to take the derivative of g by applying the product rule. In order to apply the product rule, we need to be doing multiplication instead of division. Guys, if you ever multiply, so say you're dividing 2 numbers, like 5 divided by 4, right? That's the same as multiplying 5 by 1/4, right? So, or that's 5 times 4 to the negative 1, right? Remember exponent. So that's the trick that we're going to use here to turn this division problem into a multiplication problem. Okay, so we're going to turn division into multiplication. So let's do that for b. So I'll literally turn this 1 over x into x to the negative 1. And now I have the product of 2 functions. I'm going to apply the product rule. So let's do that here. So the first times the derivative of the second. Now the derivative of the second, I bring the negative 1 out front, x to the, and then I subtract 1 from that, so that's negative 2. So that technically reduces to negative 1 over x squared, okay? Whenever I use my exponent rules. So negative 1 over x squared. And now, so I did the first times the derivative of second, plus the second times the derivative of the first. Remember this, x to the negative 1 is 1 over x, right? That's where that comes from, right there. Okay, times the derivative of the first. So the derivative of 5x to the 4th is 20x cubed. The derivative of 7x squared is 14x. And the derivative of 3 is 0. Now, simplifying here, x squared in the denominator, x to the 4th in the numerator, the top wins by 2. So it's negative times a positive is a negative 5x squared. And then I have x squared and x squared cancel, but a negative 1 and a 7 make a negative 7. And then this times this, that's just negative 3 over x squared. Now multiply through here, 1x in the denominator, 3 up top, the top wins by 2, so that's 20x squared. 1 in the denominator, 1 in the numerator, those cancel, and I just get 14. I can combine like terms here. Negative 5 plus 20 is 15 x squared. And then I have negative 7 and positive 14 makes 7. And then I have minus 3x squared there. And guess what? This matches with this right here, which is exactly what I want. Okay? So maybe this is a little bit easier than using the quotient rule. But let's try C. C says find g of x by manipulating the function algebraically to differentiate without the product or quotient. That means if we're going to do that, I need to figure out how to multiply this in a way that I can just use the power rule. Well, guess what? If I'm taking this big fraction divided by that, I can divide each of these individual pieces by x to reduce it. So 5x to the fourth divided by x is 5x cubed. 7x squared divided by x is just 7x. And then 3 divided by x is 3 over x. Now 3 over x reduces, right? 3 over x, the negative exponent if I bring it up to the numerator, okay? So when I take the derivative of this, that's 15x, and then subtract 1 gets me squared. And then derivative of 7x is just 7. And the derivative of this, I bring the negative 1 out front. That's negative 1 times 3 is negative 3, and then minus 2. But remember, negative exponents go to the denominator, so that gets me negative 3 over x squared for my final answer there. And that just so happens to match all three of these here. Now, what can we say looking at all these three different options? I think it's clear to say that C is definitely the easiest. So if all they say is find the derivative of the function, by golly, if you can avoid the quotient rule, avoid it at all costs. That thing is a booger to calculate. Okay, so if there's something that you can do algebraically to simplify it, think about this, how much easier taking the derivative of that thing was versus taking the derivative of this thing right here. And they're both equivalent to each other as long as x is not equal to 0. And by the way, if x was equal to 0, you'd be dividing by 0, and that's no bueno. Okay? So even avoiding the product rule is good to do if we can just limit ourselves to just using the power rule. Power rule is probably our quickest, easiest rule to use. Okay? So anytime that you can algebraically simplify, do it. Okay? And if you can't algebraically simplify all the way, you know, it's definitely a clever technique to turn this quotient rule into a product rule. Okay, and that's very easily done with taking this positive exponent here, and when you flip it to the numerator, it turns it to a negative exponent there, and then you can apply your product rule at that point. Okay.